Okay, so here's the homework for solution of multiple linear equations. So the first three are using elimination. And I guess that's a -6. Okay, in this case, we actually don't need to multiply either one of the equations by anything because we've got plus 2y and minus 2y. So we just add the two equations together. So x plus x is 2x, -6 plus 2 is -4. Divide both sides by 2. So you get x is -2. And then we can plug into either one of the original equations. So we use this one here, first one. So you get x is -2 plus 2 times y. Guess I don't need those parentheses. 2y is equal to -6. So we add 2 to both sides. So -6 plus 2 is -4. Divide both sides by 2, we get -2. So the solution in this case is going to be -2, -2. So we will double check the result here by plotting these two functions, seeing where they intersect. Now you need to put them in slope-intercept form. So if we do that, here we'd get 2y is equal to -x minus 6, or y is equal to -1/2 x minus 3. And then this one, same kind of deal. You get -2y is equal to -x plus 2. Divide by -2, you'll get +1/2 x minus 1. So these are the two equations that we need to plot. I'm just checking to make sure I think I did it right. We'll find out when I plot them. Okay, so the first equation is y equals -1/2 times x minus 3. And the second equation, and I don't need this equal sign in here. -1/2 x minus 3 and 1/2 x minus 1. And you can see they intersect here at x equals -2, y equals -2. So that is correct. Problem number 2, x plus 5y is equal to 10, and 3x minus 10y is equal to -5. So what I'm going to do is I'm going to multiply the first equation by -3. So that becomes -3x minus 15y is equal to -30. So all these become negative because of the negative in there, 3 times as much. And then you have the second equation. So if we add these two together, that eliminates the x. And so we get -25y is equal to -35. So we get y is equal to -35 over -25. And if we divide them by 5, we get +7/5. And then you can substitute back in. We'll plug into the first equation. So we'll get x plus 5 times y, which is 7/5, is equal to 10. So 5's cancel out. And if we subtract 7 for both sides, we'll get x is equal to 3. So it's x equals 3, y equals 7/2. And the equivalent expressions here are going to be, if we solve for y, we'll get -1/5 x plus 10 . 1/5 x minus 10y is equal to -5. 1/5 x minus 10y is equal to 3. So it's x equals 3, y equals 7/2. And the equivalent expressions here are going to be, if we solve for y, we'll get -1/5 x plus 10 . 1/5 x minus 10y is equal to 3. So it's x equals 3, y equals 7/2. plus 2. Okay. So what happens is this becomes negative, and then you divide by 5. So you get negative 1/5, and then 10 divided by 5 is 2. So that's the first equation. The second equation would be, this would become negative, but you're dividing by negative 10. So that would become positive 3/10 x. And then this one, negative 5 divided by negative 10 would be plus 1/2. So I think that's right. Let's see what we get. So we get y is equal to negative 1/5 x plus 2 and 3/10 x plus 1/2. And find this point of intersection. It's right here. And so x is 3, which is the answer we got, and y is equal to 1.4, and 1.4 is 7/2. So that is correct. Okay, number 3. 5x plus 6y equals 24. 3x plus 5y equals 18. Now, this is one of these cases where you have to multiply each one of them by something to get some common term. So we could multiply this by 3 and this by 5, or negative 3. I guess what I'm going to do is multiply this by negative 3. I'm going to multiply this by positive 5. So what I'll do is it'll make each of these negative 15. So the first equation multiplied by negative 3 is going to be negative 15x minus 18y is equal to negative 72. So if you take each one of these and multiply by negative 3, you'll get that. And we're going to multiply each term in the second equation by 5. So 3 times 5 is 15. 5 times 5 is 25. And 18 times 5 is 90. Now we add these two equations. These two go to 0. Here we have 7y, 25 minus 18. And here we have 90 minus 72, which is 18. Divide both sides by 7, so we get y equals 18/7. And then we can plug that back into either equation. So we'll plug it into the first equation. So you get 5x plus 6y, but y is 18/7, and that equals 24. So we get 5x, 18 times 6 is 108 sevenths, equal to 24. 5x equals 24 minus 108 sevenths. Now 24, if you take 24 times 7, you get 168 sevenths. So 168 divided by 7 should be 24. And then you subtract 108 sevenths. So that's 60 sevenths. 186 minus 108. And then you divide both sides by 5. So you have 60 over 5 times 7. 60 divided by 5 is 12, so you get 12 sevenths. Okay, so those are the two solutions. And again, to plot this, we'd have to solve for y. And I'm just doing this to check my answers. I don't expect you to do this, but hopefully you can see what I'm going to do. This is going to become negative on the other side, and I'll have 5 divided by 6. I'll have 5, 6x, and I'll have 24 divided by 6, which is 4. So that's the first equation, and the second equation is going to be negative. So it's going to be negative because this goes to the other side. Negative 3/5 x. And 18 divided by 5 is 18/5. So those are the two functions. Let's go back to standard view here. So you get negative 5/6x plus 4 and negative 3/5 x plus 18/5. Graph those and you see this intersection point. So we'll zoom in on that. It's right here. So we get x is about 1.7 and y is about 2.6. So what do we have here? We have x is 12/7. If we look on the right hand side, just get my calculator out. So x is 12/7, which should be 1.7 something. So it's 12/7. 1.714, that's pretty close. And y was equal to, what do we get for y? 18/7. So the y value, which is 2.587, should be 18/7. So let's take 18 divided by 7, 2.57. Yeah, there we go, 2.57. Okay, so that is correct. So those are elimination. The next three are substitution. So we've got the first one, which is x plus 3y equals 5, and 2x plus 3y equals 4. Now, you're looking for something that just has a coefficient of 1. So that's what I'll solve for. So to solve for it, that means to move the other stuff to the other, everything to the other side. So we get negative 3y plus 5 equals x, and then we'll substitute that in there. So you get 2 times negative 3y plus 5 plus 3y is equal to 4. Multiply this out, so you get negative 6y plus 10 plus 3y is equal to 4. Combine these two, you get negative 3y, and then you have 10, 4 minus 10 is negative 6, and divide both sides by negative 3, so you get y is 2. And then you can use this substitution equation. So you get negative 3 times 2 plus 5. So that's negative 6 plus 5, which is going to be negative 1. So we have the point negative 1 comma 2. So that's your point of intersection. And again, just check to make sure I did it right. You have, if you solve for y here, you'll get y is equal to negative 1/3 x plus 5/3. So move that to the right hand side. It becomes negative, divide by 3. So you get negative 1/3 plus that. And the second equation, again, you're going to solve, divide by 3. So we get negative 2/3 x from this part. And then we have 4/3. And the answer should be negative 1, 2. One-third x plus 5/3 and negative 2/3 x plus 4/3. Graph that, and here's our solution, negative 1, 2. Okay, number 5, 4x plus 2y equals negative 10, and 3x plus 9y equals 0. Now I'm going to solve for x because that'll make it so I don't have any fractions. So you get 3x is equal to negative y, 9y. or x equals negative 3y. So that's my substitution. We'll use that later. Plug that into the first equation. So for x, we put in negative 3y. Second term stays the same. So that's equation 1 with x substituted in as a function of y. So you get negative 12y plus 2y is equal to negative 10. Add these together, you get negative 10y is equal to negative 10. Y is equal to 1. And then you plug that back into here. So x is equal to negative 3 times y, which is 1. So you get negative 3. So our point of intersection is going to be negative 3 comma 1. Okay, let's write out the equations again. So if you solve for y, you'll get negative 1/2 x, 2 divided by 4. Actually, it's the other way around. Negative 2. So we get 4 divided by 2 is 2, and then it becomes a negative, and then you have negative 10 divided by 2, which is going to be negative 5. So that's the first equation in slope-intercept form. And if you solve for y here, instead of for x, we'll get negative 1/3 x. So x is negative 3y, or y is negative 1/3 x. Okay, so those are the two equations. So the second equation is going to go through the origin. Okay, so the first equation is negative 2x minus 5. And the second equation is negative 1/3 x. And we say the point of intersection should be negative 3, 1. So we got negative 3, 1. There we go. And then the final one of the substitution problems, number 6, is we have negative 3x plus y is equal to 2, and 12x minus 4y is equal to negative 8. Okay, so you can see the first equation just got 1y, so that's one I'll solve for. So if I solve for the first equation for y, I'll get positive 3x plus 2. Let's just move this to the right-hand side. And then I'm going to substitute that in here. So we get 12x minus 4 times y, which is 3x plus 2, and that equals negative 8. Okay, multiply this out. So we get negative 4 times 3, which is negative 12x. And we get negative 4 times 2, which is negative 8. This is a special case one, so we haven't talked about it in class, but what you get here is 0. You get 0 equals 0. And what that means is, how did I get 0 equals 0? Well, you can see these added together. 12 minus 12x minus 12x is 0, and then you get negative 8 equals negative 8, and if you add 8 to both sides, you get 0 equals 0. So what you find out is if I plot these two functions, and again, I guess I have to write them in terms of the slope-intercept form. So if I solve this one for y, I'll get y is equal to 3x plus 2, and then the second equation, let me just show you. We subtract 12x from both sides, get that, and if you divide both sides by negative 4, you get by negative 4 you get that, and that by negative 4 you get that, and that by negative 4 you get that, and you can see they both end up being the same equation. So when you get 0 equals 0 as your answer, that means that it's the same line, and so there's not one point of intersection. They're the same curve, so we have an infinite number of solutions. That's what we say. Okay, so now we're going to go on to the next 5 problems, which are using this reduced row echelon form. So we're going to start with 7. So we have negative 2x plus 5y is equal to negative 42. I think I made these so that we get integer answers. It may not appear from the original problem, but I think it does work out that way. So what we do is we create this thing we call a matrix, which consists of the coefficients of the x, y, and the right-hand side. And we put them all into one little group like this. Okay. And again, what we're trying to get is 1 here, 0 here, 1 there, and then we can, once we get a 1 here and a 0 there, then the y answer is here, and then we can use back substitution to find x. So the first thing we're going to do is we're going to divide row 1 by negative 2, or you can think we're multiplying by negative 1/2. Same thing. So, and we're going to replace row 1 with that result. So let's do that. So if we multiply negative 2 times negative 1/2, we get positive 1. Then we get negative 5/2, and then we get half of 42, which is 21. We change the sign so that becomes 21. Okay, now, and we just write down row 2. I haven't changed that any. The next thing we're going to do is we're going to take row 2. I'm going to do these separately. We're going to take row 1, sorry. We're going to take row 1 and multiply by negative 7. What we're trying to do is get negative 7 here, and then we can add it to row 2. So let's do this first. Row 1 by negative 7. So we get negative 7, negative 35 halves. So 5 times, and it's going to become positive. So the negative becomes positive because of the negative here. So you get 5 times 7 is 35. Then we have 21 times 7, which is going to be 147. Okay, so that is row 1 multiplied by negative, I'll get a negative sign there. So negative 7 times 21 is negative 147. Okay, then we have row 2, which is, so we're going to add that to row 2. So that's what we get here, 230. So we get is 0. Here, 35 halves plus 2. Well, 2 is 4 halves, so we get 39 halves. And here we have 147 minus 147 plus 30, so that's going to be minus 117. Okay, and we're going to replace row 2 with this result. Okay, so now we have 1, negative 5 halves, 21, 0, 39 halves, negative 117. Okay, so we got 1, 0. Now we just need to take row 2 and multiply by 2/39. So when I multiply 39 halves by 2/39, we'll get 1 here. So we know that's going to happen. The question is, what happens when I get negative 117 times 2/39? Well, let's plug that into my calculator. You can plug it into your calculator. So 2 times 117 divided by 39 is 6. Okay, so what we're going to do is we're going to multiply row 2 by that and replace row 2 with the result. So now what we have is 1, negative 5 halves, 21, 0, 1, 6. Okay, so that's where we want to get to. And what that says is y equals 6, so that is a whole number. And then now we can go back and use the first equation, which is x plus minus 5 halves y is equal to 21. And let's multiply everything by 2. So we get 2x minus 5y is equal to 42. Now I'm going to substitute in. So we get 2x minus 5 times y, which is 6, equals 42. And something doesn't seem quite right. The reason I'm saying that is I don't think I picked a number that I'm going to end up with a big number, and I know I didn't do that. So let's see what could have gone wrong here. It might have been that looks right. Let me just plug it back in here and see if I can figure out, yeah, that's something is wrong. Because what if I do, if I plug that back in here, y equals 6, I get that. So I get 7x plus 2 times 6, that's 12. So let me pause here for a second. Okay, I found my mistake. So here I had, it's right here. Here's the mistake. That should have been negative 6. So that's negative. So y is equal to negative 6. Okay, let's see what we get now. So what we're going to do is we're going to stick in negative 6. So that gives us 2x plus 30 equals 42. And so if we subtract 30 from both sides, we'll get 2x equals 12, or x equals 6. So my two solutions are y equals x equals 6 and y equals negative 6. And you could go back and plug that into the original equation and see that. So we'll just do that. So what we said was x equals 6, y equals negative 6 is a solution. So if we plug that into either one of these equations, we should get an equality. So we get negative 2 times positive 6 plus 5 times negative 6 is equal to negative 42. So this is negative 12, negative 30, negative 42. You get negative 42 equals negative 42. And you could do the same thing in the second equation. 7 times 6 plus 2 times negative 6 should equal 30. 7 times 6 is 42. 2 times negative 6 is negative 12. So you get that's true. Check, check. So that's the solution. Okay. That's why it's important to go back and check things, which I didn't do, but I realized something was fishy going on because I knew that I had to pick numbers that were in the single digits and I wasn't going to get that. Okay, number 8. So we've got negative x plus 2y equals -1, 5x minus 10y equals 6. So we put that in matrix form. So that's what we got. Now, you can see I can get a 1 in the first row by just multiplying everything by -1 and replace with the result. So what I'll get is 1, -2, +1, 5, -10, 6. Okay, now I'm going to take row 1, multiply by -5, and add to row 2. So let's take row 1 and multiply row 1 by -5. You'll get -5 plus 10 minus 5. So that's each one of these multiplied by -5. So this is R1 times -5. And then we write down R2. And then we add them together. We get 0. Did I write that problem down wrong? That one looks a little fishy too. I'm not doing a very good job here. Actually, I think I may have picked this one out of the book, so I can't guarantee it. But what will happen here is if you add these two together, you'll get that. So if we replace row 2 with this scenario, so we're going to replace row 2 with the result. Okay, so what this second row is saying that 0 equals 1. Well, never happen. This can never happen. So there are the cases where we did a previous problem where the first row and the second row were identical to each other. And so we got 0 equals 0 ultimately. And we said that was where they're the same line. What we have here, if you notice, if you look at the original equation, that the ratio between x and y is a factor of 2. 10 is twice 5, and 2 is twice 1. And then the signs are changed. But one's positive and one's negative. So what this is saying is that these two lines are parallel, but they're not the same line. So what we get, if we plotted these two lines, we'd get something that looks like that. And two parallel lines never intersect, and so you get no solution. So that's actually what's going on there. I think this is the last three that I... Okay, so let's continue on here. Problem number 9. So we're going to create this augmented matrix with the coefficients in front of the x, y, and then the coefficients on the right-hand side, constants. So what we could do is we could switch row 1 and row 2. That's because this entry, row 1, column 1, is 1. So we want to get that in row 1, column 1, instead of row 2, column 1. So we just switch the equations. Just same two equations, we're just changing the listing order. Okay, now what we're going to do is we want this to go to 0. So what we're going to take row 1 multiply by -2, and then we're going to add to row 2 and replace row 2 with the result. So let's kind of do that. So we're going to take row 1 multiplied by -2. So that's these by -6. So you get -2, -8, -66. So this is row 1 multiplied by -2. Let's write down row 2. And we add those two together. So we get 0, -9, -63. Okay, so we can then replace this augmented matrix with 0, second row with 0, -9, -63. Okay, now we're going to take row 2 and divide by -9, or multiply by -1/9, same thing, and replace that with row 2. So row 1 stays the same, so we get 1, 4, 33. And if we divide everything by -9, we'll get 0, 1. -63 divided by -9 is +7. So now we have the answer. We have that y is equal to 7 from here, 1, 7. And then we're left with the equation x plus 4y equals 33. That's the first equation. So we're going to plug in 7 for y, which we just calculated. And so we'll get x plus 28 equals 33, and 33 minus 28 is 5. So our solution is x equals 5, y equals 7. And you can plug those back in to the original two equations, and you should get them to work out correctly. Okay, number 10. So our matrix is going to be 1, -3, -19, 3, 7, 23. So we see that row 1, column 1, which is this entry, is 1 already, so everything's great there. So we're going to do the same thing we did last time. We're going to take row 1, multiply by -3, add to row 2, and replace row 2 with the result. So let's write out, take row 1, multiplied by -3, so that'll be -3, +9, and -3 times -19 is +57. Okay, and here's row 2. So add those together, you get 0, 16, 80. So 9 plus 7 is 16, 57 plus 23 is 80. Okay, so now what we're going to do is we're going to rewrite row 1, which remains unchanged, and row 2 is going to become 0, 16, 80. Next thing is to get a 1 here, so we're going to take row 2 divided by 16. So that becomes 1, and 0 divided by 16 is 0, so it doesn't affect this entry. So we get the first row, which is 1, -3, -19, and the second row will be 0, 1, and 80 divided by 16 is 5. So we get y equals 5, and then we can take the coefficients from the first row, x minus 3y is equal to -19. substitute in the value y that we got. So I'll have 3x minus 3 times y, which is 5, equals negative 19. So that this is negative 15, so if you add 15 to both sides, you'll get y is equal to negative 4. I mean, x is equal to negative 4. This is an x. So our solution is x equals negative 4, y equals 5. Okay, then we have number 11. 5x minus 7y is equal to negative 31. So let's put the coefficients here. So we get 5, negative 7, negative 31, negative 2, 4, 16. Now, you'll notice that row 2, everything's divisible by 2. So we could take row 2 divided by negative 2. So row 1 stays the same. Row 2 becomes 1, negative 2, negative 8. So this divided by negative 2 is 1, 4 divided by negative 2 is negative 2, 16 divided by negative 2 is negative 8. And then we'll switch row 1, switch with row 2. So that gives us 1, negative 2, negative 8, 5, negative 7, negative 31. Okay, so we got the first thing we wanted to get accomplished, which was to get a 1 in row 1, column 1. Okay, so now what we're going to do is we're going to take row 1 multiplied by 5, negative 5, add to row 2 and replace row 2. So row 1 multiplied by negative 5 gives us negative 5, positive 10, and positive 40. So each one of these numbers here multiplied by negative 5 gives us that. And then we have row 2, and we add them together. So this goes to 0. 10 plus negative 7 is positive 3, and 40 plus a negative 31, or 40 minus 31 is 9. So what we can do is now take our matrix and replace row 2 with this new result, which is 0, 3, 9. And then we're going to take row 2 divided by 3. Because we're trying to get a 1 here. So we got 1, 0, 1. That's the whole idea. So the first row stays the same. And the second row becomes 0, 1, 3. So what that's saying is y is equal to 3. And the first row says that x minus 2y is equal to negative 16. So we're going to plug that y equals 3 in there. So we get y minus 2 times 3 is equal to negative 16. Or if you add 6 to both sides, you'll get x equals 10. Let's double check. For some reason that doesn't seem right, but let's try it out. So what we have is the solution is x equals 10, y equals 3. So if we plug that in the first equation that we started with, you're going to have 5 times 10 minus 7 times 5, or 3. So that's 50 minus 21, which is 29, which is not what I got. So something is wrong. So let's go back and look at this. Make sure I copied everything right here. So 5, negative 7, negative 31, negative 2, 4, 6, 10. Divide row 2 by negative 2. Okay, switch them. Okay, then we're going to take 5 times, negative 5 times row 1, which is going to be negative 5, positive 10, positive 40. There. Add these together. That seems right. The reason I got the fact that I got an integer makes me think that I think I did something wrong in the next step. Oh, there we go. I don't know why I wrote 6, negative 16 in there. So let's fix this. Okay, so that's negative 8. So we get x minus 6 equals negative 8. Add 6 to both sides, you get x is equal to negative 2. So our solutions are x equals negative 2, y equals 3. Let's check that out. Let's go back to the original equation. So we got 5 times x plus minus 7 times 3, which is negative 10, minus 21, which is negative 31, so that checks. And then we got negative 2 times negative 2 plus 4 times 3, which is 4 plus 12, which is 16, so that's check. Okay, so that's good. Okay, so now we're going to get into the more difficult ones, but it's the same procedure, it just takes a longer time. So now we have 3 equations and 3 unknowns. The unknowns are x, y, and z. And what I did here was I probably should have, I mean, you can design these things so they come out to be more mathematically easy, but you know, we're going to deal with a lot of fractions here. It's just the bottom line, because as you can see, none of these that I can divide by some common factor. So we're going to end up with fractions. The good news is the answers are whole numbers, but that's not much of a consolation. So because none of these look any better than others, I'm going to just take row 1 and divide by 3. So this becomes 1, then you get 2/3, negative 5/3. At least here we get the whole number. Then we have the remaining terms in the other rows. So all we're doing is taking row 1 and dividing by 3 to get 1 in this first spot. Okay, now what we're going to do is we take row 1, now that I've got a 1 here, we're going to take row 1, multiply by negative 5, add to row 2, and replace. So let's multiply row 1 times negative 5. So you're going to have 5, negative 10/3, so 2 times negative 5. Then we're going to have positive 25/3 and negative 30. So let me double check on this, because you know, you make one mistake and you're out of luck. So you got to be really careful about this. Okay, then we're going to add to row 2. So that's 5, negative 4, 3, negative 12. Actually, this should be negative 5 as well. Okay, negative, negative, positive, negative. That's the sign should be different. Okay, you add these two together, you get 0. Here we'll have negative 10/3 minus 4. So we want to replace these with thirds. So that's going to be 12 thirds. 4 times 3 is 12. So you get negative 12 thirds plus negative 10 thirds. That's negative 22 thirds. Here, we have thirds again. It's 9 thirds. 9 thirds plus 25 thirds is 34 thirds. And adding these together, you get negative 42. So that's going to be the new row 2. But before we do that, let's go ahead and also get a 0 here. So we're going to take row 1, multiply by negative 4 instead of negative 5. We're going to add to row 3 and replace row 3. Here we replaced row 2. So let's take row 1 and multiply by negative 4. So we get negative 4, positive negative 8 thirds, 4, it's negative positive 20 thirds, and negative 4 times 2 is negative 8. Did I do something wrong there? Why did I get 30 here? That doesn't seem right. That's not right. So because I went up here, I need to pay attention to what row I'm on. So this is actually negative 10. So this is going to be negative 22. Okay, let's do it again here. So we're going to take row 1 multiplied by negative 4. So this should be negative 8. So it's negative, negative, positive, negative. The original was positive, positive, negative, positive. And you can see that all looks good. And so we add that to row 3. So add those together, you get 0. Here we have 8 thirds plus 15 thirds, so that's 7 thirds. 15 minus 8 is 7. Here we have negative 6 thirds, so that 20 minus 6 is 14, so we get 14 thirds. And 15 plus negative 8 is 7. So that's going to be row 3 now. So let's go ahead and just replace this. So this is the two operations that I ended up with. The first row stays the same. So we get 0, negative 22 thirds, positive 34 thirds, negative 22. Third row we get 0, 7 thirds, 14 thirds, 7. Okay, so that's my new matrix. Now what we're going to do is we want to get a 1 here. So to get a 1 in the second row, second column, we're going to multiply by the negative reciprocal of that. So we're going to multiply, we're going to take row 2 and multiply by negative 3 over 22. And then we'll replace that. So row 1 stays the same, so we get 1, 2 thirds, negative 5 thirds, 2. The second row is going to become 0. 0 times negative 3/22 is 0. Negative 22 thirds times negative 3/22 is 1. The next one we're going to have is negative 3/22 times 34 thirds. So you see the 3's are going to cancel out. So we end up with negative 34 over 22, which is negative 17 over 11. And then we're going to take this 22, so we get negative 3 over 22 times negative 22, so that's going to be equal to, these are going to cancel out, and we end up with a positive 3. So this becomes 3, and the last row stays the same. Okay. Now what we're going to do is we're going to take row 2 and multiply by negative 7/3 so that we get the negative of that here. So if we do that, so let's take row 2. Let me just write it down. 1, 0, 1, negative 17/11, 3, and multiply it by this. So we get 0, we get negative 7/3, and then we got to multiply this, so it's negative 17/11 times 7/3, whatever that is, and then 3 times negative 7/3, negative 7/3. So let's simplify that down. So you've got 17 times 7, which is, what is it, 119? So it's plus 119 over 33. And then here we have 30's cancel out, so you get negative 7. Now we're going to add that to row 3. So this is row 2 times that. Everything's sitting, so you add that to row 3. I'm just hoping I did this right. So I see a problem. Right now I'm going to get one of them things is going to be 0, which is not what I was looking for. Because if I add these two together, I'm going to get 0, 0, and here you get 133 over, well, no you don't, because you got to put these in terms of 33rds. So if we multiply this by 11, we'll get 33, and that by 11 we'll get 151, I think. I need to get my calculator out. So if I take 14 times 11, this is 154 over 33, so you add 154 and 119, and you get 273 over 33, and here you get 0, which is the problem I see with this. So that makes me believe I made a mistake unless z is equal to 0. So I'm going to pause for a second. Actually, that is the right answer. So what we get here is, because what we get is 273 over 33, z is equal to 0, you get z is equal to 0. So once you have z equals 0, you can go back into this equation. So you go back to this second equation. Where am I? Let me find it here. So you go here. So let me finish this off here. So you get 1 2/3, negative 5/3, 2, 0, 1, negative 17/11, 3, 0, 0, and you get 273 over 33. And 0. So what this is telling is is that z is equal to 0. So this time 0 is 0. What you're left with is the next equation, which would be y, 1y minus 17/11 z is equal to 3. Well, if z is equal to 0, this goes to 0, and you get y is equal to 3. And then you could go back to the original equation here, which would have, you'd have x plus 2/3 y minus 5/3 z is equal to 2. But z is 0, and y is 3, so I get x plus 2/3 times 3 is equal to 2, because that drops out. So I get x plus 2 is equal to 2, and I get x equals 0 is my solution again. So I actually get 2 zeros and a y solution of 3. I'm surprised. Maybe. So I think I got these. I guess must have got this one out of the book because I didn't know what my solution. These other ones, the other ones that I, where are the other ones? Yeah, I think these are the ones that I came up with myself. Let's double check. Yeah, so that first one I got out of the book, which I hadn't done before, so I didn't know what the solution was. But yeah, the next ones have solutions that are not 0. So let's go ahead and do those. Surprised I didn't make a mistake. Okay, so we got 5, 3, -1, 0, -1, 2, 3, -5, 3, -1, 2, 11. Now what I'm going to do first is I'm going to multiply this one by -1, and I'm going to switch places. So it's going to become 1, -2, -3, +5. So that's row 2 multiplied by -1. And then it's going to be row 1 becomes row 2. So I'm switching. I'm doing two things at once here. And row 3 stays the same. Okay, so again, I took row 2 multiplied by -1 and then switched row 1 and 2. Now, let's leave those here. Let's take row 1 multiplied by -5, add to row 2, and replace row 2. So let's write row 2. Let's take row 1 times -5. So that's going to be -5, +10, +15, -25. And then we add to row 2. Like that. And we get 0, 13, 14, -25. And that'll become our new row 2. Then we'll also take row 1 times -3. That's to eliminate that out of there. And add to row 3 and replace row 3. So if we take row 1 multiplied by -3, we'll get -3, +9. Is that right? No, +6. -2 times -3 is +6. negative 3 times negative 3 is positive 9. And negative 3 times 5 is negative 15. So that's 3 times a row 1. We add that to row 3. And you'll get 0, 5, 11, negative 4. So now we can rewrite the matrix. 1, negative 2, 3, 5, that stays the same. Row 2 gets replaced with 0, 13, 14, negative 25, 0. Row 3 gets replaced with 0, 5, 11, negative 4. Okay, let's go back and check this, because once you make one mistake, you're shot. You're done for. Okay, left, right. Same thing down here. Okay, so that looks right. Okay, now what we're going to do is we're going to take row 2 and multiply by 1/13. And what that's going to do is it's just going to get us a 1 right here. So we'll get 1. Here we'll get 14/13 and negative 25/13. So that's pretty easy. You just divide everything by 13. Keep row 3 the same. Okay, next thing we're going to do is we're going to take row 2 times negative 5, add to row 3, and replace row 3. So let's take row 2 and multiply by negative 5. So you're going to have 0 times negative 5, 1 times negative 5. Here we'll have 14 times negative 5. 5 times 14 is 70. So we get negative 70/13. And then we take negative 25 times negative 5. That's 125. So we get plus 125 over 13. Because you've got the negative times the negative becomes positive. 25 times 5 is 125, and you divide by 13. And we add that to row 3 there, so you get 0, 0. Here we need to put this in terms of 13ths. So let's do this separately. So you get negative 70/13 plus, take 11 times 13 is 143. So you get 143 over 13. So 11 is 143/13. So we get 143 minus 70. That's 73/13. 73/13. And here we're going to have 125/13 minus 4. So 4 times 13 is 52, so minus 52/13. So 125 minus 52 is 73. 73/13. So what we end up with is replace that with row 3 with that. So we get 1, negative 2, negative 3, 5, 0, 1, 14/13, negative 25/13, 0, 0, 73/13, 73/13. So the next thing we do is we divide row 3, or multiply by row 3 by 13/73, okay? Because 73/13 minus 13/73 is 1, and the same thing here. So what you'll get is 1, negative 2, negative 3, 5, 0, 1, 14 thirteenths minus 25 thirteenths, 0, 0, 1, 1. And what that says is z, 1z equals 1, or z equals 1. So that's my z solution. Now I can plug that z equals 1 into here, and so the second equation is saying 1y plus 14 thirteenths z is equal to negative 25 thirteenths. But I know z now, so I can plug that in. So I get y plus 14 thirteenths times z, which is 1, minus 25 thirteenths. And the reason I'm hesitating is I don't think this should come out to be an integer. It doesn't look like it's. Oh, it is. Okay, yeah. So what you get is y, if you subtract 14 thirteenths from both sides, you get negative 39 thirteenths. 25 plus 14 is 39. And that's negative 3. So you get y equals negative 3. And then you go back to your original equation, the top equation here, which is going to be x minus 2y minus 3z is equal to 5. And I've got y and z from previous, so I get x minus 2 times y, but y is negative 3, minus 3 times z, z is 1, is equal to 5. So now I solve for x. So you get x plus 6 minus 3 equals 5, x plus 3 equals 5, and x equals 2. So my solutions are, my three x, y, and z for the one solution is x equals 2, y equals negative 3, z equals 1. And that's the only combination of x, y, and z which will give you a solution to all three of those equations. So that wasn't too bad. So that was 13. Let's try 14. Okay. So this is the last one. So we create our matrix 1, 2, negative 3, negative 4, 2, 3, 1, 11, negative 3, 1, negative 2, negative 7. So we've already got row 1's where I want it. I've got a 1 here, so I don't have to do anything there. So I'm going to take row 1 multiplied by negative 2, add to row 2, and replace row 2. Okay, so let's take row 1 and row 1 multiplied by negative 2. So you get negative 2, negative 4, positive 6, positive 8. So these are all these numbers multiplied by 2. Here's row 2. And again, I chose this number so that when I added these two together, you get 0 in the first entry. So you get that. Here you get negative 1, 5, 19. Okay, so now I can replace row 2 with 0, negative 1, 5, 19. Now I'm going to take row 1 multiply by positive 3, so that when I multiply it by positive 3 and add it to row 3, I'm going to get a 0 here. So I'm going to add that to row 3 and replace row 3. Okay, so row 1 times 3. So I'm going to get 3, 6, negative 9, negative 12. Okay, I'm going to add that to row 3. So you get 0, 7, negative 11, negative 19. So that's my new row 3. Okay. Next thing I want to do is get a 1 here. Well, that's going to be easy because I've got a negative 1 there. So all I'm going to do for the next step is I'm going to take row 2 and multiply it by negative 1. So the first and the third rows remain the same. So I get 0, 1, negative 5, negative 19, 0, 7, negative 11, negative 19. Next thing I need to do is get a 0 here. So to do that, I'm going to take row 2 and multiply by negative 7, so that these, when I add these two together, I'll get 0. So I'll take row 2 by negative 7 and then add to row 3 and replace row 3. Okay, so let's write row 2 times negative 7. So 0 times negative 7 is 0. 1 times negative 7 is negative 7. Negative 7 times negative 5 is positive 35. And 19 times 7, negative 7, or negative 19 times negative 7 is 133. So that's this row multiplied by negative 7. Then I add it to row 3. So I'll get 0, 0, 24. Then 133 minus 19 is 114. And that doesn't seem right, because I'm getting I'm just looking to see if I had a common factor here, because I'm going to, if I take 114 divided by 24, I don't get a whole number. So let me pause for just a second. Okay, I found an error. So this should be 7. So let's see what that does. Then this becomes a 7 right there. And the rest of it's right so far. And then the second one is here. So I'll pause again, make sure I did that. Okay, so then this, when I change the sign, this becomes positive negative 7 right there. So when I come down here to this part, I'm going to so this becomes, instead of positive 35, it becomes positive 49. So negative 7 times negative 7 is 49. And when I add these two together, 49 minus 11 is 38. So that's going to be row 3. And if I take 114 divided by 38, hopefully that's an integer. It is. Okay. So the next thing I'm going to do is take row 3 and divide by 38. So what will happen there is I will leave row 1 and row 2 the same. And I'll get 0, 0, 1, 3. So what that says is z equals 3, which is the right answer. Then I'll take that result and go to the second equation, which says y minus 7z equals negative 19. So I've got y minus 7z equals negative 19. So you get y minus 7 times 3 is negative 19. Y minus 21 equals negative 19. Add 21 to both sides, you get y equals 2, which is the right answer. And then finally go back to this original equation, the first equation, the first line of the form. So you get x plus 2y minus 3z is equal to negative 4. Negative 4. So I know what x and y and z are. So y is 2 and z is 3. So now I can solve for x. So you get x plus 4 minus 9 equals negative 4. X minus 5 equals negative 4. Add 5 to both sides, so you get x is equal to positive 1. So my solution is x equals 1, y equals 2, z equals 3. And that's the correct solution